we have the different security rings. And device security kind of fits right in here at physical and port level. Okay, your communications port, your COM port, your auxiliary port. All right, your virtual terminal ports. That's not necessarily physical layer, but that's the next ring. Okay. If you don't have a device that's locked down from a secure physical standpoint, anybody can walk up and take control of it. If I can physically get my hands on a router, a switch, a firewall, I can reset the password and own it, period. So, but if you have that router, switch, firewall, server, yada yada, in a cage, it's locked, and that cage is in a data center that has man traps to access it, and a security guard, you know, some guy with a gun and dogs roaming around and security cameras. That's a harder server or switch or firewall or whatever to access, right? You'd be surprised at how many customers I go to that they just have their network infrastructure readily available for anybody to walk up and open the janitor closet and grab it. Okay? So the physical security piece behind everything is just as important as the network security piece. That's kind of what I'm driving at. But device hardening also takes it to the next level because you want to be able to harden the device so that remote users or remote abusers do not have the mechanisms or means to take control of your network hardware. And that's where device hardening comes in, which is where we're going to talk about your virtual terminal lines, your VTY lines, your COM port, your aux port, your password policies that you put onto a device, username and password pairs, as well as security levels. So tonight you're going to get a demonstration of the first common hack that is used against a piece of infrastructure equipment or common infrastructure equipment with Cisco. I'm going to show you how to hack a level 7 hash off of a Cisco router and how by using a MD5 hash is much more secure. A lot of the default services on your router, switches, firewalls, infrastructure equipment need to be turned off unless you have an absolute need for them. Okay, when I say an absolute need, you need to make sure that you have a few additional security layers in place for those services to be adequately hardened. The most common one is your HTTP and HTTPS engines. Okay? Routers, switches, firewalls, you can all administrate them today via graphical user interface or GUIs. It makes things easier, I know, it's point and click and you can fish around for stuff and figure it out and also break it a lot easier too. But by rule, it's best to configure those devices by command line or CLI, command line interface. Telnet, we want to get rid of it. What would we put in place at Telnet? Who knows? What would we put in place at Telnet? SSH, secure shell. Okay, why? Correct. SSH is encrypted by default. Okay, it sets up an encrypted connection between the devices. Okay, via RSA key. FTP. We want to get rid of FTP if at all possible. What would we replace FTP with? Anybody know? Secure FTP, which is the SSH equivalent of, Telnet. And we're going to talk about password types. Type 5s, which is type 7 and clear text. Type 7 is a less secure password type. Type 5 is for MD5 hash sums. And you never, ever, ever want to have anything in clear text. I'm going to talk about the service password policy that is default on all Cisco equipment, okay, and should be deployed. So, in setting up password encryption, service password encryption is your command. By default, in your configuration, you'll have a no in front of it. So you need to ensure that it is in place by typing service password dash encryption. Okay? You don't have that in your config, you'll lose probably 3, maybe 4 points on this lab. By the time you get to the final, if that's not in place, you'll lose a letter grade. Very important. Securing the BIOS. ROM-MON hardening, this is a little tricky. Okay? This is a little tricky. This is the only way that you can ensure that guys like me who can get their hands on, if they can get their hands on a piece of infrastructure equipment, can't change the password. I cannot put in a keystroke break sequence, break into ROM-MON mode, and change the password. This has to be done in remote monitoring shell in order to break the break sequence. Not impossible to recover, but a whole heck of a lot harder. You actually have to break open the box, switch out jumpers, and reset it from firmware. Okay, really hard. This is what the hackers at CCDC were doing 2 weekends ago, and really messing with some of the teams, because they would completely lock them out of their boxes, regardless if they tried to do a password recovery. The only way to get past that is to reset a jumper and firmware. User accounts in iOS. This is the command sequence to set up a user, which is one of the questions on your first lab. Username, the username. Password, the password. Privilege, the privilege level. Setting the privilege exec commands, privilege exec level, all, pound, then command. Go ahead and look at that example on page 61. Also on page 61, how we lock down our virtual terminal lines. If you type in the line command, line space VTY space 0 space 4, which will bring up all 5 lines simultaneously for you to input commands. If you would type in the command login space local, it will look towards the local usernames for your username password pair. I'll go over that here shortly, and it'll make a little bit more sense when you see it. Your common aux port security. You want to still set passwords on these ports, regardless of whether you use them frequently or infrequently. Your aux port, unless you were going to have a modem set up for it, and what a modem would be set up on your aux port for would be out-of-band management, meaning I'm going to use a telephone, a modem, and dial into a router or switch or firewall to administrate it via command line. Now, I know that sounds very archaic. However, it is very secure. All right, it is not terribly hard to set up, and you can implement controls in that in which you can have the router actually call you back, and you can set up a list, a caller ID list, so if it recognizes the number, it will allow you to connect, disconnect that number, dial you back. So if I'm trying to do PSTN DTMF manipulation and do a hack from the front side, it'll disconnect and call me back. If I answer, I can connect. If it's somebody else, it's not going to go to them. Okay? Anybody ever heard of a guy named Dark Tangent? DT? He's the creator of the DEF CON conferences. That's what he was most famous for, was DTMF manipulation. Know how to configure the aux port for reverse telnet. What reverse telnet will do is once you connect in via the modem, it will do the dial back and initiate the telnet session from the router instead of from the workstation. Now, banners. Banners are still a necessity. They're fun to play with. They're honestly, it's your warning message. So if somebody does break into your router, you can at least give them the final last opportunity to quit without getting in trouble. Because what you'll learn later on in the class is logging. Anytime anybody logs into a router, okay, a message is sent to a syslog server, and we find out what username and password was used. Okay, we set up AAA, authentication, authorization, and accounting. The accounting piece will follow their entire command sequence. Okay, it's like a keylogger. Okay, but you put in a banner basically to tell somebody, hey, stop. If you are not authorized to be on this system, you will be prosecuted to the fullest extent of the law. Okay? And by the way, I'm logging everything. I will find you. Securing the boot image. Okay? Under Cisco iOS, you can set up resilient configurations. Okay, in order to encrypt your boot image. We're not going to do that in this class because I don't want to make things too terribly complicated on you. Alright, but you can enable encryption within your boot images, so if anybody breaks into it and tries to manipulate the actual .bin file, the binary file, with a worm of any type, or a backdoor, or an embedded keylogger, they can't do it. That's kind of going to extremes, but it helps prevent the manipulation of your binary file. Different Cisco services that we want to turn off. Okay, Cisco Discovery Protocol. Cisco Discovery Protocol can be very, very helpful to both you, the administrator, and to a hacker. Because instead of having to, what we call, crawl the network with conventional tools like Nmap or Nessus or Armitage or something of the like, we can use CDP. And we can look up CDP and find all the infrastructure equipment, routers, switches, firewalls, phones, access points, wireless controllers, yada yada. And get all of their IP information, all their name information. Turning off TCP, UDP small servers will disable some features of TCP and UDP that are not needed. Same with the finger service, or boot services. ID protocol, which is the predecessor to CDP. DHCP and boot P, okay? This can be very important if you're running a voice network, okay? Or if you are running a certain devices on your network that need immediate access to addressing. And then you don't want to mess around with a Microsoft DHCP service. I really personally do not like Microsoft DHCP. I think Microsoft has made it way, way, way too complex and too easy to manipulate. This is my personal opinion, it's not a best practice by any stretch of the imagination. I would rather see DHCP ran on infrastructure equipment, or even better, on a Linux server. Trivial File Transfer Protocol, TFTP, and File Transfer Protocol, FTP, should only be turned on if you are hosting images on a router or a switch that have IP phones connected to them, such as your phone loads, your phone firmware. Okay, and that's the only time you would have that on there. And auto-loading commands. All right, auto-loading commands are to tell the router where to go get its firmware, where to go get its configuration. You can manage it to the level where you have everything centralized in one server. That may be taking it a little far, but it gives you tighter control when a router, switch, firewall reboots. ARP, proxy ARP, and gratuitous ARP, address resolution protocol. ARP is very, very malleable, especially on switches. We'll get into that when we talk a little bit about layer 2 security, as we will with directed broadcast, redirects, mass reply, ICMP unreachables, SNMP, network time protocol, and HTTP, which you've already touched on a little bit already. There are certain things that you want to turn off on interfaces, and these are all related to interfaces with the exception of the last three. We don't want to allow the manipulation of ICMP. Okay, ICMP is great. I'm sure we use it all the time to find out if Google is up, or if CNN is up, or if we can see our gateway. That's great. That's echo. That's just one single flag within an ICMP protocol header. All these other different pieces within ICMP can be manipulated for bad things. Okay? The easiest way to take care of that is to take out ICMP unreachable on your interfaces, to take out IP directed broadcasts and IP redirects off your interfaces, and IP mass reply off your interfaces. It's not going to break anything, all right, especially on a local network, but it will make your network more secure. SNMP, for those of you who just got out of 437, what version of SNMP do we want to run by default? 3. Why?
It has enhanced security tests. It's not. I mean, it takes longer to set up, but.
It takes longer to set up. True. Packets are encrypted.
Yeah.
Okay. And it's not in clear text. That's the biggest thing. Okay. You don't have dedicated write in SNMP3. Okay. You have to have a username password pair in order for write commands to be executed. Now, all that stuff that we just talked about, you can learn how to do each individual command. That's great. There's also an auto-secure feature. It talks about it on page 75 of your text. And here you'll find commands to enable the auto-secure feature. It's very powerful. It runs through a script that's embedded, and it will turn things, like I just talked about, on or off. It's designed to turn many of the features that are not needed in everyday administration and operation of iOS. So I'm sure you have questions. So if you have a question, shout it out. I'm going to get into the GNS3 portion of tonight and what you're going to need for Lab 1, which Lab 1 is due when?
Thursday.
Thursday, right.
Next week.
No. Wrong answer. Looky there. Love it. An hour and 12 minutes. Nice. All right, cool. Enough of that.
Searchable, or is it only by link?
If you type in CIS 467, I am sure you'll find it. Let's test that theory.
Did find it. You got it? Yeah.
30 minutes, 14 minutes, an hour.
Work. Who was able to upload the whole hour? That's what I was.
Part 1, part 2.
The whole hour was just the one in the middle.
We want to take lunch break or watch the entire thing?
Nice. Part 3. Very cool, very cool.
Subscribe.
So make sure when you post it up there, that's chapter 3 we're doing tonight. Chapter 3/Lab 1. Very cool. All right, so back to the lab here. So tonight what we're going to go over, this is Lab 1. We're going to lock down a single router. I'm going to pull over a 3745 in GNS3. We're going to console to it, give it a host name, I'll probably make one user, show you how the password encryption works. We'll set up an interface. We'll set up an IP on that interface, default route. I will go through how to set up DHCP. For those of you in 347, that'll be a refresher. Standard access lists. Went over that last week. May do one real quick, but from a different IP. Now I'm going to set up the router to use Telnet on the VTY lines. This will be the only lab that you get to do that on. I will also set up the router to use SSH, which is very important that you take note of because you need to do that moving forward. We're going to lock out the aux port, disable the HTTP engine, disable Cisco Discovery Protocol system-wide. I'll also show you how to do it on a per interface basis. So let's get started. Okay, so I'm going to name this project Lab 1 Sample. And I'm going to go over a 3700. You don't have to pull over a cloud. I'm just going to show you how this works because for those of you that were in 347, clouds are used to configure connection to your own device, to your host device, like through either a Microsoft loopback address or a VMware adapter. So all I have to do is a little bit larger. Drop that down and I can see all the different connections that I have. I have my wireless connection, I have my host adapter, my VMnet 2 adapter, my VMnet 8 adapter. I am just going to select my local area connection. Click Add. I'm going to select my local area connection. That's my gigabit Ethernet port. Okay? Apply. Okay. I'm going to go ahead and set this up for manual. I'm going to set up F00 to the switch and F01 to the cloud. Okay? You don't have to go to this link in your lab. I'm just kind of giving you a primer here so you can see how it works. And now I'm going to turn the router on. I'm going to green up. Console to it. Okay, it comes up and it already has a host name of R1. So, to get into privileged exec mode, what's the command I use? Enable, or just EN for short. Now, if my host name was, say, router, or I wanted to change my host name back to router, what would I have to do? No, I have to go into a configuration mode called global configuration mode. How do I get to global configuration mode? Config T or conf T. Now I use the host name, and as you can see, my prompt changes. Okay? I'm going to change that back to R1. Okay, so we're 20% done already. We've created a router in the console. Okay, it has 2 Ethernet ports, and I gave it the host name of R1. 20% done already. So now I'm just going to set up a user and password. So I had a user of what? Root? Oh, admin and Cisco. So to set up a user, you use the command user, which is short for username. Then the username, which in this case is admin, and then the password, our password short, which I'm going to make the password Cisco. All right, and he has privilege level 1. So if I ever get confused on a command, what's the keystroke that I use? Question mark, and that's the help, right? So user. Privilege, so admin, I'm going to give him a privilege of level 1 and a password of Cisco. Alright? Now if I ever want to look and after I put a command into a router and make sure it took or inspect it, but I'm in global configuration mode or interface configuration mode or router configuration mode or line configuration mode, how do I look at my show configuration? Do show run. Now if I was just in privilege exec mode where I have the pound sign, would I use the do command? No, I just type in show run. So, see that right there? We're going to come back to that in a second. Password encryption. There, you see my username, admin, password, 0. Okay?
Reason why it doesn't show the privilege?
Because privilege level 1 is default.
Ah.
Alright, privilege level 1 is default. So here's what I'm going to do. I'm going to put in the command service password encryption. I'm going to do show run again. This time I'm just going to hit the up arrow twice. Now you see password encryption has been invoked. So let's look at the user again. Hey, I no longer see Cisco, do I? And that 0 is changed to a 7, right? That's pretty cool. That's really cool. All right, we're going to come back to that. Keep that in mind. Let me get through the rest of lab 1. All right. So I want to set one interface with that IP address. I'm going to make that the inside address. So that would have been fast Ethernet 00 because it's connected to switch port 1. So I'm going to interface fast Ethernet 00. My prompt changes to the interface configuration mode. And I'm going to type in the IP address, or I'm going to create the IP address, which the command is IP add 192.168.20.1. And that's a /24. So there it is. Now, am I done with that interface? No. What do I have to do?
No shot.
Why do I do no shut?
Turn it on.
Because I turn it on. Very good. You guys good at this stuff. Excellent, excellent. Good job. All right. There. Interface came up. Set the other interface, or the outside interface, to that. So that's going to be fast Ethernet 01. So int f0/1 IP add 204.168.29. That was a /30. And I have to turn that one on as well. Good. God, we're 50% of the way done. Define a default route. Now, this is where you have to take a note. Now, we talked last week about OSPF. Remember that dynamic routing protocol that I put on? A lot of times in routers, you're not going to have a routing protocol to participate to your internet service provider. Okay, because unless you're running a very large network that is multi-home to at least 2 internet service providers, you're not going to run a dynamic routing protocol to the internet. So you're going to have to set up a default route. What a default route is nothing more than a pointer that says if you cannot find the path or the way to your network, go that way. Okay? It tells where packets should go. Now, looks like I'm getting a mismatch here on my connection to my gigabit Ethernet port. So I'm just going to make a quick correction. This is not necessary for you guys, but I don't want to see that error. You don't need to do that though. Yep. All right. So to set up a default route, I have to be in global configuration mode, and to get from interface configuration mode to global configuration mode, I'm just going to type the word exit. It backs me out one phase. The command to set up a route, any route, whether it's a default route or a standard static route, is IP route. All right. Typically, the next number would be the network that you're going to. All right. Followed by its network mask. But since I want to set this as a default route, I want to match any IP that's not already known. So I do that by a series of zeros. 2 sets of 4 zeros separated by periods. 0.0.0.0 space 0.0.0.0. All that is saying that if nothing else is matched, go to this IP address. And I put in the IP address. In this case, that IP address is going to be 204.186.29.30. That is a default route. DHCP. To who is in 347? Who's in my 347 class? One. Nobody else? Okay. DHCP. You have to do 2 things for DHCP typically. It depends on what I'm asking for. So I want to set up DHCP for that network. I want to exclude 1 through 25, and I want to set up the DNS servers that are served up from the DHCP for those 2 addresses. So first thing I'm going to do is I'm going to set up the DHCP network. So command is IP DHCP pool, and then I give it a name. Name is arbitrary. I'm just going to type in lab 1 pool. I could make it my name, I could make it my pool, I could make it whatever I wanted to. I hit enter. I now go into a configuration mode for the DHCP server. In order to set up the DHCP for that specific network, I give it a network command, just like if I were doing with a routing protocol. Network 192.168.20. And then the subnet mask, which is a /24. to set up the DNS servers, I could pretty much just cut and paste that right there, letter B. DNS-server, I said pretty much. 192.168.20.16. Space, the next server, 204.186.20.53. And I think I can put quite a number of DNS servers, and it goes in a sequential fashion. Okay? That's it. If I wanted to set up a default router other than my router, I would put in the command default-router. I'm not asking for that here. I don't have to. To do the exclusion, I actually do not have to be in the pool to do the exclusion. So what the exclusion means is basically I don't want the DHCP service to serve out .1 through .25. So I'm going to exit out of the DHCP configuration, and I'm going to type in the command IP DHCP space excluded -address. And I put the beginning address followed by the ending address. I think that's right. Let me check my work before I hit enter. Yep, 1 through 25. Now if I look at the configuration, see my excluded address, there's my pool, my network, my DHCP servers. 70% done. The last 30% is easy. We've already seen it before. So, set up a standard access list on your router to deny any traffic from that network into your network. So, I didn't really was specific, so I didn't say where to set this up from. But what are the two things if we're setting up a standard access list we have to remember? If we're going to deny a network, what should we permit after it? If we're going to deny a specific address or range of addresses or network, what do we have to do after that statement, that initial statement? What? No, that's what we're doing.
Apply it to an interface.
Apply to an interface is one, but before we do that, we have to add an extra entry into a standard access list. Otherwise, we're going to block all traffic because there's an implicit deny at the end of an access list. And if we don't do that, no, we have to do a permit IP any. Okay? If we're going to specifically filter one address, a group of addresses, a list of addresses, we still have to permit something at the end of it. Okay? We have to remember that. So, but if that was a statement to say, I only want this network permitted, we would permit that network and then deny everything else. So, command is access list. A standard access list is 1 through 99. I don't care what you pick. I'm going to pick 10. Deny 117.23.54.0. What do I have to do here? Inverted or wildcard mask. I got an email on this the other day. Very good. Stating, why did I do this wrong? I'm seeing zeros, all zeros on my access list. And I looked at his command he put in. He or she sent me their config file, and they put in a net mask, 255.255.255.0. That's going to be wrong because it has to be inverted. So it's, in this case, it would be 0.0.0.255. And here's where we have to do the permit. Otherwise, it's going to break.
If you're ever unsure of which one you have to do, if the inverted or the other one, you can just do question mark and it'll tell you, right?
Actually, a standard access list is IP anyway, so it's just access list 10 permit any. What was your question again, sir?
If you're ever unsure if to put the subnet mask or the wildcard, you can just put a question mark and it'll tell you, right?
Yep. There's the access list. Now, I'm going to apply this access list on Fast Ethernet 01 inbound. I wasn't specific in the question. If you do it somewhere else, I'm not going to count off points. As long as it's applied somewhere, you'll get full credit. Okay? Again, baby steps. So I'm going to go into interface F01 and type in the command IP access group 10 inbound. Again, I wasn't specific. You made it outbound, inbound. Either way is fine. You just have to make sure it's done. Okay? You'll get the full 10 points. If you do the access list but forget the access group, you'll lose half your points. If you do the access group but you mess up on the access list, if you try the access list, you'll get some points. You may lose 2, 3 points, right? But you won't lose all 5. Most people lose 5 because they forget that. Now, set up your router to use Telnet on your VTY line. So now we have to go into VTY line, or VTY mode. So, that's how I get into my lines, my virtual terminal lines, VTY 0 and 4, 0 space 4. I'm sorry, line VTY 0 space 4. And you see my prompt changes to config-line. Okay. To enable Telnet, I have to tell it transport input Telnet. Means it's going to accept Telnet as a transport, as the only transport protocol. If you put in transport input all, that would be fine too, because it would still accept Telnet. Okay? And then I have to tell it to allow logins to happen, which would be login local. I could set a password on the VTY line itself. That would be perfectly fine. Alright? But that would be a shared password by all. By setting up users in a device, I get some form of control.
I just have a question. Do we get to see the Telnet protocol?
What do you mean, do you get to see it?
Get into it or use it? The protocol, the actual protocol?
Yes, I can do a demonstration of how to use it. I did that last week. I believe I did that last week. But hold off. I'm gonna get to that piece of the class. It's actually really neat. All right, and the last step: lock out your aux port, disable your HTTP engine, and finally disable Cisco Discovery Protocol system-wide. That is 3 commands. First off, let's start with the auxiliary port. So line aux 0. To lock out any port, your console port, your VTY port, your auxiliary port, you just have to take executive privileges away from that port. So, no exec. If I put in no exec on that port, I cannot open up a terminal session, regardless of protocol. Regardless of protocol. Disable your HTTP engine. From global configuration mode, no IP HTTP server. Disable Cisco Discovery Protocol. No CDP run. No CDP run. That disables Cisco Discovery Protocol. Let's write this to memory, shall we? Now, I'm not going to exit out. I'm going to kill this connection here real quick. I'm going to bring another router over. Power him on. Switch over here. This guy kind of looks familiar, right? So I'm going to quickly console this guy. I'm going to put the 200 address on him real fast. Which was 204.186.29.30. I think my access list is killing everything, so 1 second. I'm just going to kill the access list here. Alright, what is your major malfunction here? Bet you I know what it is. Nope. Yeah. Two oh four dot 168, 204.186. See how that can get really confusing really fast? It's 186. So I put in fast Ethernet wrong. I put the IP address on fast Ethernet 1 wrong. Much better. There we go. Okay, now I have connectivity.
Why is it 80?
Huh?
Why is it 80%?
It just took a second for the protocol to come up when I was pinging it. Int f0/1. When troubleshooting connectivity problems, one of the first steps to do is disable access list to make sure that it's not a filtering issue. Because as you can see, as soon as I put that filter in, not a good thing. Take the filter out. Oh, 186. Sorry, I'm an idiot. Put it back in. Ping the right address. There we go. So the filter's in. All right, good. Status quo. Sorry about that. So, you know, as I had told you before, we had this service password encryption, right? Everybody got that?
Yeah.
Okay. So, when we, if I were to telnet from R2 to R1, okay, I'm going to a password prompt. My username was admin. My password was Cisco. All right. I got a user prompt. Now, fortunately, I had no password set for my enable password. So, I have to set an enable password. Just going to make it Cisco. If I look at my enable password, hey, it has a level 7 hash as well. Okay. Let's make it a little bit different this time. Let's not make it Cisco. Let's make it root. Enable pass root. Let's write that to memory. Okay. Now when I tell that back, admin Cisco enable root. Now, as you can see, I'm actually in R1. So I have a shell or console into R1. Okay? Now, okay, great. You got to use username and password. Let's do this. In GNS3, and if anybody can ever gain access, physical access, to a switch, for whatever reason, and set up a span port or a mirror port, you can sniff packets. If you are on a wireless network and you are working with Telnet or you are working with remote access, wireless can be sniffed. So if you are not using any encryption whatsoever, if you're in clear, all right, all somebody has to do is start capturing. In this case, I'm bringing up Wireshark, which is the protocol analyzer. Okay. I'm just going to generate some traffic here from R2. Bunch of ping packets and everything else. Now Wireshark is, I have to kind of update it here. View. There. So if I hit the refresh button, you see all my pings that I did, my replies. Good stuff, right? So now, if somebody's doing a packet capture, if I telnet to R1, Ask me for my username. Okay, admin logs in. Gives it its credentials. And I have privilege exec. Okay. If I scroll down this packet capture, oh, now all of a sudden, I start seeing different things. There's CDP. Now I shut off CDP on R1, but I'm still seeing CDP ARP to try to discover its network. Okay. I see a telnet session start. Here's your the beginning of your TCP three-way handshake that starts on telnet. I look at the conversation. I see telnet data going back and forth. Wireshark is powerful. All I have to do is go up here to analyze, follow TCP stream of the one that I'm highlighted on, the first packet or around the first packet. What I have to remember is it's seeing a duplicate stream, so I just have to take out every other letter. There's my username, admin, my password, Cisco, my enable password, root. Right? Okay, no problem. For argument's sake, let's say I do a TCP transfer, or excuse me, a TFTP transfer from my router, I'm backing up my file, to a centralized TFTP server. It's good practice. You need to do it. You need to keep good backups of your configurations. Okay? If you're doing that via TFTP, TFTP is encrypted. Let's just say, for argument's sake, I'm in R1 and I do a show run. Okay? Now I go back to my packet capture. Okay, and I see all this telnet data. Let me go back and follow that again. Now, look what I just got. I just got my config. So, I'm a bad guy. Somebody's using telnet. I got his username, I got his password, I got his enable password. There were additional credentials here. Oh, but wait. Hey, I put this in, didn't I? Oh, I'm good. I got it encrypted. I'm solid. No. Copy. Gotcha. Gotcha. Okay? So here's where you have to be really, really, really careful when hardening a device that you use an MD5 level hash. Alright? So how you do that is, instead of using username password, you use username secret. So let's do that real quick. Let's go on my regular shell.
For a lot, do we just use password instead?
No, use secret. That's why I'm going through all this dog and pony show, okay? Username, admin, privilege 1, secret, Can't have both user password and user secret. So what I have to do is I have to take the username out, no user, admin, then I can add it. Now look at what happens when I do a show run. Oh, that's my enable password. User. Quite a different hash, huh? Quite a different hash. Not impossible to crack, but sure as heck not as easy either. Alright? Take your enable password out and change it the same way. Use enable secret as your password pair. Do a show run. And you can now see that my enable secret has a much stronger hash to it. Again, okay, yeah, I can run that through a rainbow table and get it relatively easily, but still not as easy as a level 7 password. Okay? This is why we have to have layers and layers and layers and layers of security.
Can we go beyond that in this class?
Beyond what?
This level of password?
No, because you're not going to have anything within the system to do that, unfortunately. Okay? So what you would do instead is make sure that if you are transferring any files, you're using an encrypted means, whether it's SFTP or you are moving them off of a out-of-band network to where nobody's going to sniff the traffic, or you're very sure nobody's going to sniff the traffic. You never use any type of remote administration over a wireless network, ever. Okay, encrypted or not. Okay, or if you have to, you ensure that you are using at least a very strong encryption mechanism, which we'll get into when we get into wireless security. So, fun? Cool. Questions? Yes, sir.
So let's say you're a hacker.
All right.
You're sniffing traffic.
Yep.
Can the company...
And you're breaking 5 federal laws right now. Okay, go ahead.
But, can they, the security of their company, sniff you sniffing the traffic?
Yes, that's absolutely plausible.
A lot of
That's allowable. Because that traffic on your network is your property. Okay? It is your domain. So you can sniff your own traffic all you want to. All right? You don't have to worry about privacy issues as long as you announce it, especially to your employees. Okay? If you in your employee handbook say, at any time I reserve the right to monitor, administrate, and analyze network traffic for any reason, I warned you about it. Okay? So what if I catch Johnny or Susie or Sally or Mikey surfing on Facebook? Shame on them. Right? Or if I catch Rex cracking into one of my servers, well, Rex is going to talk to Mr. Sheriff.
So that's why they move a lot. They could just keep using,
Who moves a lot?
like the hackers, for
What?
instance. Do they keep changing?
What typically a lot of hackers do, good hackers do, is they will go multiple layers into a zombie network in order to use a system that will not be traceable. For example, I have a workstation on Cal Poly's network. I can remote to it from a library computer. I now have 2 layers deep. I take that zombie here at Cal Poly and I go to and capture a computer at Mount SAC. I take that computer and then jump over to one at, Southern California Edison. I jump from that one to somewhere else. I go multiple layers deep, right, before I actually start looking for the target computer that I want. Okay? That's why network forensics is so very, very, very important. Because if I can track traffic and analyze it and look at it, I can trace all of that back. Okay, as long as I have the end station at some point in time. Alright? If I don't have that end station,
If you have one in the middle,
sorry?
if you have one in the middle, it doesn't matter.
I'm only going to get part of the conversation. Right? I won't get the full conversation.
So it doesn't really matter how fast of a hacker you are because if your packets are being captured.
A lot of times, hackers use command line. They don't use GUIs at all. They will find the files and transfer it to a host somewhere out there for retrieval later. And what good, really good hackers do is they will cover their tracks. They will find all of your system logs where they logged in. They will find all of your event logs if it's a Windows box and delete them. The really, really good ones will only delete those events that they placed.
That way it doesn't look like they deleted it.
Right.
What's the difference between like the default route we set up and setting up like a default gateway?
Nothing.
So for like
If you have a single node network like this, a default gateway is just fine. All right. If you have a very large network, you want to use a default route because you can take that default route and inject it into a routing protocol. You cannot do that with a default gateway. So a simple network like this, they're one and the same. A very large enterprise network where you may be using a routing protocol and you have your head-end router that goes to the internet that has that default route. You can take that default route and put it into the routing protocol so that all the other routers know where the exit is.
On the topology, on lab one,
Yep.
you really had the router.
I'm only looking for one router. I use that second router just to do examples.
So do you want us to put any hooks on there or anything?
Nope. Good questions. Anything else? I thought I was over here somewhere. No? Yes?
do you know again what you use that cloud for?
I just use that as a connection from my PC. I ended up not using it anyway. We'll get to that later on in the class when we get into the ACS server.
Can you show us how to save like the config and show us
Sure.
what you're doing?
Absolutely. Thank you for reminding me. So I need to save my config, right? So I'm on R1. First thing I'm going to do is I'm going to do a write mem. Okay? And just for giggles, I'm going to do a write mem on R2. And so I don't blow anything up here, I'm going to stop my packet capture. Somewhere there's a stop here.
Can I just close Wireshark?
Yep. So, I come to GNS3, and I've already started a project. As you can see, I have c:\temp, lab-1, sample, whatever it is, right? Topology.net. All I have to do is go here to File, Save. You see these two lines? You want to make sure that you get both of these configs. You want to make sure you have both those configs. Your check. Let's go to that directory. c:\temp, lab1 sample, configs. There's my configs.
We only have one because we only have one.
Right. So you're going to send me R1. You're going to send me this. Okay? That's it. Good questions. Very good questions. Any other questions?
So if we wanted to email it, we just have to send that one file.
Yeah, one file. Please do not zip one file. That annoys the you know what out of me. I took a 5K file and compressed it into 4K. Great. You are such a green monster.
I mean, like the 16K pipe back
Yeah.
then. Or a floppy disk.
Yes.
For the purposes of this class, do you care whether we use password or secret?
Oh yes.
Right?
Use secret. Because you've now been informed of the dangers. You know, and here's the thing. You would be surprised at how many customers I go around to, and they don't have any password encryption at all set up. Period. Just shows the password. And they're like, I need to change this. And where did you change it last? Home. Really? Yeah. Oh, what's worse is I changed it from Starbucks. This is the best time of year for me to go sit in Starbucks. You know why? Especially on Saturdays and Sundays. Not that I do this on a regular basis or often or at all. Right? But it's amazing to see how many people actually do their taxes online at Starbucks. Yeah, it boggles my mind.
You're kind of asking for it.
Yeah, it boggles my mind. I mean, I really want to sometimes go up. If I would not be breaking laws, and I would not break laws. You know, and show them their 1040 on my screen as they're filling their stuff out. You know, right before I delete it. So pass the word to your family, to your friends that are doing their taxes this weekend or next. You know, don't do it over public Wi-Fi. I still, to this day, fill my taxes out by hand. I do. I absolutely do. I will be the last person on the planet to do my taxes electronically. I will.
Even if you take it to an accountant?
What's that?
Even if you take it to an accountant or lazy?
I do my taxes myself. I'm a smart enough person, I can do my taxes myself.
What if we already?
I've never been audited, knock on wood.
I guess we're screwed because I already emailed mine.
Whoops! From Cal Poly on the guest network, right? Winning. Any other
On the
questions?
library computer.
But should be safe at home, right? No?
You know what? When we get into the wireless network piece, actually, I'm not going to be teaching wireless networking. One of my former students, alumni from here, he's worked in the forensics for a forensics company. He works for me right now at NIC. David Hunter is going to come and teach wireless, and he is really, really, really good in that topic. Ask him about his home wireless network. Ask him about my home wireless network. It's a little bit off the hook.
When does he come and teach here?
The 19th. The 19th. So he's already agreed. I'm going to have him teach. I'm going to shift the syllabus up just a little bit. I'm going to take layer 2 and move it back and move wireless up. Wireless security up. So it'll be really good. I'm working on that lecture for that night. And hopefully he'll do some demonstration stuff as well. We'll bring some access points in and play around with that and have a good time. Because wireless security is just as important as the networking stuff.
When you have the simple encryption that like a Linksys router has on a home network, how does the packet sniffing go on those?
You have to have some sort of, it's very important to know what chipset you have on your wireless card, because you have to have a certain chipset on your wireless card in order for it to work in what they call promiscuous mode, in order for you to sniff packets wirelessly. All right? So, preview for this, all right?
Mine to go and do the same.
Internet. Time Warner cable. My DOCSIS modem. My Cisco 871 router. Alright? my Cisco 1142 access point. I have a 3550 switch. I have a 2008 AD server. And I have roughly 5 PCs, the PlayStation, the Apple TV. Oh God, what I have the kids' Xbox. All right, and then I have a 2003 server with ACS. Okay. So I have laptops that are authenticating here and everything else. So the wired network is pretty secure. Running a domain, the PCs that are wired in, and there's some that are going through wireless. They all authenticate off the domain. That's working really good. On the wireless, I'm using WPA2, AES with TKIP. 100, and I'm sorry, AES is, I think it's 256 bit encryption. Okay.
Is it possible to break AES?
Huh? What?
Is it possible to break AES encryption?
I'll get to that. Okay? So, the access point authenticates via LEAP to the ACS server. Okay? Or is it PEEP? It's PEEP. LEAP is bad, PEEP is good. Alright? So the access point authenticates to the domain. Alright? Laptops, the cell phones, the Blackberries, the PCs that are on wireless, they go through and they have the encryption. They have a username and password pair that they have to use that authenticates them via the ACS to the Active Directory. All right? That's how people get onto my network. That's how my kids surf the internet. And it's all done through their AD credentials. All right? Cool. My next door neighbor. Done.
Well, yeah, because he didn't change the default password.
Yeah. All right. Which network are you going to jump on? Okay. To answer your question, yes, it is possible with enough computing power and enough time to break a 256-bit AES password. You're sitting outside of my house in a van doing that. You are going to meet me, my German Shepherd, okay, my Golden Retriever, and my 44 Magnum. Log in here. Any other questions? Really? I see a challenge. Right on, man. Good night.